Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with IgniteNet. Today's host is Tony. He is their Vice President of Sales, and he'll be presenting today. If anyone has any questions, please submit them in the question box, and Tony will answer them at the end of today's presentation. Tony, thank you very much for being with us today. I am finished for now. Please go ahead and take it on over.
Excellent. Thank you, Julie. Thank you for the opportunity to present an introduction to 60 gigahertz technology and then a brief overview of the product portfolio that IgniteNet has that addresses some of those needs for fixed wireless and high-speed, connectivity. So why don't we just get started here? So high-density fixed wireless. A unique challenge in certain areas, specifically in high-density markets, where there's a lot of people living in these urban high-density areas. 80% of the world's population lives in these types of areas. There's not a lot of really good choices for broadband. A lot of problems that are faced in these areas are, noise, interference, things like that, because there's tons of people. Everyone has more and more devices that they're connecting in their homes, in the workplace, and just out and about when people are shopping and stuff. So a solution to combat that is some type of 60 gigahertz fixed wireless solution. So a brief introduction: 60 gigahertz is part of the V band. That's from 40 gigahertz to 75 gigahertz. It's also sometimes called millimeter wave, if you've heard that term. It's been unlicensed by the FCC in the US since 2001, and that's 57 to 64 gigahertz. That'll give us four 2 gigahertz channels to interoperate and not have any kind of overlap or interference. Recently, I think probably about a year and a half ago, maybe 2 years ago now, the FCC added 7 gigahertz more of spectrum, so 64 to 71 gigahertz. So we'll be able to add 2 more channels to products moving forward when we come out with some new products. Some people are calling this upper band technology, if you've heard that term. So anything above that 64 gigahertz range is called upper band. And those are the new part of that new spectrum that's been recently unlicensed. The main application for 60 gigahertz is outdoor point-to-point and point-to-multipoint. There are some vendors that create indoor type appliances, maybe like gaming, where you can replace the controller cable with some type of 60 gigahertz wireless technology for faster connectivity and faster operation, but mostly used for outdoor and point-to-point and point-to-multipoint operations. A quick view of the regulatory overview. Most of us on the call are probably interested only in the US, Canada, Mexico market. Again, giving us channels 1, 2, 3, and 4, utilizing from 57 gigahertz to 64 gigahertz. One of the real good benefits of 60 gigahertz is in the frequency reuse. So the downside of 60 gigahertz is in the distance. The maximum distance, say, of one of our point-to-point solutions is around, say, 2 kilometers. At 2.5 kilometers, the signal dissipates completely in the air because of oxygen saturation at that higher frequency. So at 2.5 kilometers, you can reuse the same frequency on the same channel, in the same exact direction, and not see any overlap or issues with any kind of noise. 5 gigahertz, that frequency will go 25 kilometers before it dissipates, and 2.4 goes a little further at 32 kilometers. So it's a lot more secure and really good for frequency reuse because it doesn't propagate forever like the traditional 2.4 and 5 gigahertz frequencies would. Another benefit with 60 gigahertz is we can get that same, distance in a much smaller package. So on 2.4, you need a 60 centimeter dish to get 24 dBi of gain out of the antenna, or 30 dBi out of a 5 gigahertz antenna. On 60 gigahertz, we can have a 35 centimeter antenna, so about a 1 foot dish, and get much higher gain out of the antenna, 42 dBi. So the frequency lets us focus the antenna and have smaller antennas, so you don't have these giant dishes sitting on top of rooftops or, wall mounted on the sides of buildings for connectivity. Distances and point to multi-point is something that we talk about all the time. The current products today use channels 1, 2, 3, and 4. And at 4, so you can go around 3,000 meters, the signal, say, max. If you look at the purple, you'll see point-to-point distances are much shorter. So when you're planning a 60 gigahertz fixed wireless deployment, you want to make sure, first of all, if you're using point-to-multipoint, you could see channel 1, 2, and 3 are almost the same distance at around 500 or 600 meters. Channel 4 will give you just a little bit further than that, maybe 700 or 800 meters. It won't be until the upper bands come out, channels 5 and 6, where you see much longer point-to-point and much longer point-to-multipoint distances. So something to keep in mind when you're deploying 60 gigahertz is distance, direct line of sight, and then whether you're deploying point-to-point or point-to-multipoint. So you can make sure you have that proper, distance and you're not too far. Some of the products that we have in this technology, we have dual band products. And by that, I mean 60 gigahertz would be the main wireless technology. And all of our 60 gigahertz products have a 5 gigahertz radio built in for failover. Another downside of 60 gigahertz would be rain fade. So if you have a link that's set up at 2 kilometers and it starts pouring rain or a hurricane comes in or whatever it is, that rain will interfere with the 60 gigahertz signal. So the 5 gigahertz failover is there so that the link will stay up and running during these periods of heavy raining. It'll just slow down from, say, 2.5 gigabits of over-the-air throughput between radios down to 802.11 AC speeds, 500, maybe 550 megabits. So again, all of the 60 gigahertz products have these 5 gigahertz radios built in for that backup. And that backup is handled one of two ways. One is just an automatic failover. When the 60 gigahertz connection is no longer active, the 5 gigahertz failover will automatically kick over and it'll keep that link up and running. Or you could, as you're deploying it, you can set a minimum RSSI level and say, hey, when the signal strength gets down to this, I want you to fail over before it just fails over completely. So you can control that failover now, which is great. Some of our products are tri-band, where we also add a 2.4 gigahertz radio for access. So if you're doing like, say, a smart city and you're putting these tri-band products, say, every 300 or 400 meters down the street, you can provide the backhaul over 60 gigahertz, and you can also provide Wi-Fi access throughout the city at 2.4 and 5 gigahertz. So there's a lot of different variations of the different products that we have, some being dual band and some being tri-band, depending on, the application you're looking for. For point to multipoint, we have a couple of different options, like I said. On the left column, the first product there, you'll see it's a 2.5 gig over-the-air throughput point to multipoint sector. So this product will support up to 12 clients today. It has a 120-degree beamforming antenna. So the antenna will focus out 120 degrees by 29 degrees. And it gives you 5 gigahertz failover to all the clients connected, all 12. It cannot do 5 gigahertz access for Wi-Fi, but it does have a 2.4. I'm sorry, it doesn't have a 2.4 gigahertz either. So there's no Wi-Fi access. There's only failover. The product in the middle is what we call a 10 gig Omni. So this product will give you 2.5 gigs of over-the-air throughput on 60 gigahertz frequency, 360 degrees. So if you were doing some type of residential solution where you were trying to replace fiber or put something up temporarily while you had fiber run, or a lot of customers do, pop-up networks, like if you're doing a music event or an outdoor concert or something and you want to get some Wi-Fi access there, this would be perfect because this will give you 360 degree coverage at 60 gigahertz. It also gives you 360 degree coverage of 2.4 and 5 gig client access. And each one of those have 4x4 MIMO, omnidirectional antennas in there. So it's a really cool product for, smart cities going down the street, like I mentioned, or anywhere where you're trying to get multiple connections added. So this product has 3 independent 120-degree sectors like that previous product. So it could support 12 clients per sector, or 36 clients total, but no more than 12 on each 120-degree sector. So it's a real interesting product for a lot of different applications. Today, we're seeing a lot of deployments in the residential areas where you're putting these up throughout a street where you have line of sight and trying to kind of get around trees and other obstacles where you don't have line of sight. And then you could put a client radio on homes or businesses to get access. So we have customers that are providing gig services to businesses and homes, 2.5 gig service, and then even stepped up from, say, 100 meg, 500 meg, and whatever. So you could provide multiple different levels of services as well. The product on the right is what we call a Metrolink LW. It's kind of a lightweight internal name for it. It's used as a low-cost sector, 120 degree. It has the same 120 degree beamforming sector as the other two. It has 2.4 and 5 gig for access, but they're only 2x2 MIMO antennas, not 4x4s. And this guy will only provide 1 gig over the air throughput on 60 gigahertz. So it's kind of a smaller, lower cost version. You use this max distance, 150, say 200 meters. So whenever you're doing a small, really dense type network with multiple connections, you could use one of these as a point to multi-point sector as well. And it too will support 12 clients. On the client side of the point to multi-point radios, these are our point-to-point radios, and they're either configured in point-to-point mode as a client to a sector. Point-to-point mode as just 2 units talking to each other, or as a client that communicates to a sector. So the one on the left is a 19 centimeter antenna, about 6 inches. The one in the middle is 35 centimeters, so about a foot. And there are different versions of these products. These are called Metrolink 1 or ML1. These provide 1 gig of over-the-air aggregate throughput. There's another version of this product called the ML 2.5, which provides over-the-air throughput of 2.5 gig. So, but they look exactly the same. There's a 19 centimeter version and a 35 centimeter version. So you have multiple choices depending on the type of throughput you need. And again, these are aggregate numbers. These are not full duplex numbers. Depending on the distance you need to go between clients or between a client and a sector, there are a lot of different options that you can choose here. So some of the typical applications where we see these products deployed, I mentioned before, residential. So it's a lot easier and a lot quicker to put up, gigabit fixed wireless solutions like the 60 gigahertz products instead of ripping up streets and laying down fiber. So we have a lot of people using them as fiber replacements into residential areas, as temporary connections into a residential area while you wait for permits and while you wait for fiber to be laid. The benefit in this type of environment is, you see all these homes and, everybody's got multiple devices. I think I counted last time, I probably had 14 different Wi-Fi devices in my house now. So all of this different noise pollution and, noise and interference is coming from those types of traditional Wi-Fi devices. So using 60 gigahertz to get into a neighborhood where you can provide gigabit service to a home and potentially compete with whatever the local cable provider is in the area. My cable modem service here, the best I can get is 350 meg. If I can get a gig link somewhere, I would get a gig link tomorrow. So it's a good application for residential deployments. Business deployments, same kind of thing, right? It's way more secure in the aspect that we're talking about a client radio that has a transmission beam of between 1 and 3 degrees. So you couldn't, if you were in this type of an office application and you were going from, say, one building across the street to another office building, you couldn't really catch the signal. You couldn't hack into it. Somebody would have to have a 60 gigahertz device made by the same manufacturer and somehow get in between that 1 degree and 3 degree beam to get that signal or to steal it or to hack into it. So it's kind of really secure in that respect, because the beam width and the density of the beam is so tight, it's really hard to get to it. In the business applications, it's used just for connecting buildings, right? It's not the type of wireless technology you would use inside a building while people are at their workstations and you are getting, gigabit wireless service. So it's not used for that. It's used mainly to connect multiple buildings. And smart cities is obviously one. There's Wi-Fi popping up everywhere through a city, where you could walk through certain parts of New York City and still have Wi-Fi connectivity. The benefit of 60 gigahertz is backhauling all of those Wi-Fi access points. So they have to connect to some internet connection, and you're not going to run fiber everywhere where you have a Wi-Fi access point. So the easiest way to do it, or the cheapest and fastest way, would be to run a 60 gigahertz backhaul network throughout the city, where you can go up and down these. And the cities are great, right? You can go up and down them. There's not a lot of, interference or objects that would, give you a problem with line of sight. So you can use 60 gigahertz as the backhaul and then drop Wi-Fi access points across them as you go down these different links. And then that's how you're backhauling all of that Wi-Fi access traffic back up to the network through that 60 gigahertz backhaul. It's used a lot for video streams, connecting, cameras, video cameras, surveillance cameras, stuff like that, where you have the need to send 4K video streams, and you need some higher bandwidth application that's not susceptible to the same interference and noise that when you would get out of 2.4 or 5 gigahertz. So smart cities are a real good application for this technology as well. Other things that we do to help out make this a little easier is we have a cloud controller. The products are completely managed and set up and configured on their own. The cloud controller is not required. It's just there as a thing to help you if you had multiple different sites, and you can look at the different radios that are in a site, whether it's a Wi-Fi access point or a 60 gigahertz backhaul radio. And you can manage multiple different sites from a single location. So it's relatively low cost. It has an MSRP price of $99 a year. And that's an unlimited number of devices from, 2 to, however many you want. If you wanted to check out that cloud, you can go to cloud.ignitenet.com. It's free for the first 2 devices forever. And it only requires a license when you add that third device to unlimited. Another real important tool that's on that cloud controller is what we call the link path tool. So this is the place you would come to if you were starting to think about deploying a 60 gigahertz link. And in here, what you would do is you would pick, the master, then the client, and you would pick what radio it is. And if you hit the drop-down menu, you'd see a bunch of different radios. You'll pick the channel you plan to use. You'll pick the range zone, the ITU range zone, which will give you an idea of, how many, how much rain you get in a certain area during the year. So there's a map there. If you click on the question mark, that you could see what range zone you live in. The benefit of this is you're going to select the 60 gigahertz range reliability. And if you want 5 nines or 4 nines or 3 nines or 2 nines of reliability, you'll choose that. And then it'll tell you in the graph below what the distance in meters you can expect with rain, without rain, and then what the throughput level would be over the air. So we're looking somewhere between the green and the orange at 1,000 meters, probably around, 8, maybe 900 meters, you're getting the sweet spot of 2.5 gigs in this range zone with these client radios. So this is an important tool when you're planning it. You never want to set up a point-to-point link and choose the no rain option, say go 1,355 meters, and all of a sudden it starts raining and your link goes down and you don't know why. So it's real important that you keep note of the rain region you're in and you plan your deployment based on it. Like this says 705 meters is the longest distance for 3 gigabits of throughput with rain. I would plan, 650, maybe 600 meters if you could. Just to be on the safe side so that you get less interference from rain and you create less of a problem. So it's a real important tool when you're planning your deployments. And everyone should check it out before they put any radios up for sure. The other thing we'll talk about is mounting brackets. We have 2 options. The radios don't ship with mounting brackets anymore, because people wanted to choose which bracket they wanted to use. So they're all optional now. On the left, you have a standard bracket. Now it has some pluses and it has some minuses. We have some customers that just truly hate this bracket, and we have some that like it. The benefit of it is it gives you a lot of adjustability. Remember, if you're doing a point-to-point network, you're aiming a 2-degree beam to a 2-degree beam at, say, 1,000 meters away. We have tools I'll show you on the next slide that will help you get into the area, into the right region of it, but you're going to need to do fine tuning. So you get a lot of fine tuning option with this standard bracket, plus or minus 80 degrees. It's the only option you have if you want to wall mount one of these radios directly into a wall, not put up like a J-arm to the wall and then pole mount it. And it has a wind survivability of around 75 miles an hour. So it's okay in that respect. It requires a lot of adjustment. You need to tighten up the screws, and some people complain that when they're tightening one, another one loosens. So there's a trick to getting it to work right. And again, some people love it, some people hate it. The high precision bracket came out probably 6 months after we released the first version of products in the standard bracket. It's a great bracket. It has 125 mile an hour wind survivability. The problem with it is it's only pole mounted. So if you're going on a wall, you need a J-arm. And it only gives you plus or minus 12 degrees of adjustment. So you got to get really close with your scope and your say app or tuning tools before you adjust this guy down, because you won't have that same flexibility as you do with the standard bracket. Some of the other tools are on the right. That's a scope. We have it's basically what you'd expect. It's like a rifle scope. So it has crosshairs through it. And this is going to help you adjust your radio into the region. It's not going to get you dead on accurate. And I think it's important to note that not all two scopes are the same, right? So usually an installer carries a scope and he gets used to the fact that while it looks like it's dead center, he knows that his scope needs to be adjusted, say 2 degrees above dead center for it to work. So just keep that in mind. It takes a while you're using your scope to make sure you know how that one specific piece of glass works. But all of our radios have a mounting bracket on the top for the scope to attach to. So imperative that an installer at least has the scope so he can get the radio into the right region. And then on the left, you see we have a tool that's an Android or iOS app. And you can download that free in the Google Play Store or the Apple App Store right now. It's called Link Assist. And what that does is, with the use of a little external USB dongle, you plug the dongle into the radio on one end, and this tool is going to be right on your phone, helping you kind of get to the right, RSSI level and the right signal strength. So these are just additional tools to help you fine tune that point-to-point, deployment, so you're getting it as close to dead-on accurate as you can. And that's it. I will take any questions if there are any.
Tony, thank you very much for that presentation. We've definitely enjoyed it. And I do have some questions here ready to go. I'm going to start with the first one here. Okay, let's see here. For the tri-band flexibility, would it automatically adapt the connection for the devices connected to 2.4 and adapt it to the 5.0? Or do we have to manually connect the device to both bands?
Yeah, so that's a great question. So you can set the radio up to automatically choose the right band based on the client that's requesting access. So if there's a client that is only 2.4, you're setting a single SSID and it'll dynamically choose the right frequency for the client. Absolutely.
Thank you very much. Next question here for you. The MetroLink 2.5, 10G, and LW are all access points, correct? And it also says here they are not just CPE for point-to-point.
So yes, the ML 2.5s are client radios like these. There's a 19 and a 35 centimeter. So they're used for point-to-point connectivity between each other, but they have a client mode, so they're also used as clients when they are pointed towards a point-to-multipoint sector antenna. So they do both.
Excellent, thank you. Next question here says, what speeds will each user get based on the 12 per sector?
That's a good question. So if you, with any of the 120-degree sectors, well, not with any, sorry, with the Metrolink 2.5 gig beamforming sector and the 10 gig Omni, each of those customers is still going to get 2.5 gig over-the-air throughput aggregate, so half of that. So you'll probably get somewhere around 1.25 gig throughput. But the way the sectors work is it's dynamically allocated. So if one client's not sending or receiving and another one is, if somebody ran a speed test, they'd probably see, 1.25 gig over-the-air throughput.
Excellent. Thank you. Next question here. What's the longest link we can plan for with IgniteNet? Someone here says they have heard that it could be 1 mile shots. Is that true?
Yeah, that's absolutely true. So we tell people 1.9, 2 kilometers max, and that's about a mile. So we have some customers that are telling us that they have 2.2, 2.5 kilometer links up. Those would be people like in the Arizona desert, right, where it doesn't rain a lot and those links stay up and running. But I think the best way to plan a link is based on the link path tool, first of all, so you're not going too far. But the maximum distance, if you have direct line of sight, is, I would say, 1.9 to 2 kilometers top. So about a mile, yeah. Just a
Great.
side note,
sure.
when the upper bands come out, like channel 5 and channel 6, that gets us above 64 gigahertz, oxygen saturation becomes less of a problem. So we're looking at links that could be 3, maybe 5 miles with channel 6, and that would be obviously a new hardware platform, but there is the potential to do a line of sight 60 gigahertz link and get at least above 3 miles for sure. And that will be products that come out probably in Q4 of this year.
Thanks for that, Tony. Next question here. Will the controller ever change from 99 per year?
I don't think so, but I don't think so. It's never changed since we launched it. It's $99 a year for an unlimited number of devices. I would say you could contact the salesperson at Microcom, and if you had a giant network and you were adding radios constantly, we could find a way to provide you with a voucher code so you don't have to pay that $99. So there's certainly a way to offer it to you as an incentive to deploy more products, of course.
Excellent, thank you. Next question here. Is LinkPath a tool to calculate calculations? And if so, what is the link to access this information?
Yeah, so LinkPath is a tool to calculate the links that you plan to put up, whether it's point-to-point or point-to-multipoint. It's going to help you understand the throughput you're going to get with and without rain, and the distance you should expect as a maximum, right, where you're putting the two radios. You could go to cloud.ignitenet.com and sign up for a cloud account, and LinkPath is in that, it's in the cloud management utility. And again, it's free for the first 2 devices, so it's not a hindered or cut down or trial version. It's just the regular version. So you'll see LinkPath right there if you go to that website and sign up an account.
Excellent, thank you. Next question here. Can ML2 CPE be used as a bridge kit as well?
A bridge kit. So the ML 2.5-60-19 or 35, those are the CPE model names. Either of those can be used in point-to-point. I assume that's what you mean as a bridge kit, right? From one point to another solely without point-to-multipoint?
I would think so, yes.
then yes, those client devices, the 19 centimeter and the 35 centimeter versions, either ML1-XXX or ML2.5-XXX, those are all client devices in point-to-point where they talk to each other as bridges, or they're clients to a point-to-multipoint sector, and they're one of the 12 clients that each of those sectors could support.
Thank you, Tony, for that. Two more questions here for you. Next one, who can we email direct for additional technical sales help from IgniteNet? Is there a direct person we can email? And this is from our tech person asking.
Yeah, you can email me at tony@ignitenet.com. If it gets too technical for me, like if you want to start talking about wave patterns and signal degradation or something where I need to bring in an RF engineer, we could schedule a conference call and we could bring in an RF engineer and we can get really techy if you want.
Excellent. Thank you for that. Last question here for you. Can one use their own scope, like for hunting or for golf, to align the units?
You could. The reason why we have a scope is there's a mount directly on top of it, but you could take a rifle scope or anything you want and put it on top of it. Again, all scopes are different. Even two of the same model rifle scopes are going to give you different outcomes. So whatever scope you use the same one each time, and then you'll start to get a feeling for, while you have the app on your phone, where dead on center is versus where the scope says it is, so that the next time you do it, you'll know if you have to go up and to the right or up and to the left. But yeah, so whatever scope you choose, just stick with that same glass each time, and then installations and alignment will get a lot easier if you're using the same tool.
Thank you for that, Tony. Excellent. And thank you so much for answering all those questions today. And thanks for everyone for attending today as well. If anyone has any further questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. If you wish to view any of the products mentioned or shown here today, please visit us at www.microcom.us. And please remember, this webinar presentation has been recorded and it will be uploaded to our Microcom YouTube channel so you can view it again. Tony, thank you so much again for all of your time and your presentation and all of your information today. We greatly appreciate it.
Oh, thank you for the opportunity. My pleasure.
Thank you so much. See you next time.